Hello everyone, this is Chris Matson. This video is a pre-project release of the project objective statement. Project W13 is about people and about producing goods that are affordable and useful to people around the world. There are 7 billion people living in the world today, and according to the United Nations, over 1 billion people live in inadequate housing. The United Nations also reported that approximately 100 million people worldwide are completely without a place to live. The objective of the project is to design, construct, and test a new fundamental building element. So ideally, this would be the kind of element that could interface with itself so that we could build objects and structures that would be useful. Now, in the best of all worlds, there would be only one kind of element type. And we would want to be able to use this element type for building things like furniture or things like housing. Now, this element can be constructed in a high-tech manufacturing facility and shipped to sites around the world. So for this reason, we will be quite interested in low-cost elements and elements that can be packed in high density. Now, let's dig in a little bit deeper at 5 sub-goals. The first sub-goal is to develop a modular building system that has a minimal number of unique parts or modules. To better understand this, consider construction in the developed world. That's what this picture represents here. And in this picture, we can see at least 8 different building element types. We also can see like a large variety of dimensions to which those materials have been cut. For this reason, construction in the developed world is expensive. It takes the management of all those different kinds of element types. It takes a craftsman who knows how to size them, cut them, and assemble them together. This is one of the large reasons why housing is inaccessible to so many people in the world. It's because housing can be expensive. Let's consider the complete opposite of this. In this case, the hexayurt, designed by Vienna Gupta. This is a good representation of how construction can be handled at the complete opposite end of the spectrum. In this case, 12 4x8 sheets of foam or plywood can be used to construct the hexayurt. And starting at the top of the picture, you can see 6 of the 4x8 sheets remain intact, while 6 others are cut along the diagonal to form triangular roof pieces. And you can see how the roof pieces fit together to create the hexayurt. This kind of construction has much more of an opportunity to reach the masses of people who need housing. And here we see half a dozen hexayurt structures. The second sub-goal is to develop a modular building system that has a minimal number of unique joints or interfaces. Again, considering the hexayurt, we can see that a fiber reinforced tape is used for all of the joints. In this case, one interface type used everywhere. You can imagine the complexity that grows if we try to have different interfaces for every joint. Develop a modular building system that can pack densely into a cargo container. A different low-cost building structure that we haven't discussed is a good example of this, the quad drawer. The quad drawer, which I'll describe later, can fit into shipping cargo containers as follows. In a 40-foot long container, 1,296 quad drawer homes can fit. That's amazing. In a 20-foot long container, 648 quad drawer homes fit. The fourth goal of the project is that we develop a modular building system that is inexpensive. A great benchmark here is the shelter box. The shelter box is a box that's shipped around the world where disasters have occurred, and in the box is a number of supplies to help a family through the recovery process, including a shelter. And in 2012, the cost of the shelter box averaged $874 US. The Hexayurt with the foil backing, this is estimated to cost $500. The fifth goal of the project is that the building system be properly engineered. We should capitalize on the existing work that's been done in geodesic domes, nerodesic domes, and so many other mathematically based structures. We should contribute to that body of knowledge where possible, and we should most certainly use our best engineering judgment when going about verifying the structural soundness and these sorts of matters for whatever building elements we arrive at. It's essential for any new element to be evaluated against existing elements, especially with regard to loads that can be held, both vertical and horizontal loads. It's also essential that we evaluate joints. This is some of the joint work that was done as part of a great report called Analysis and Construction of Nerodesic Tridomes. This was written by Maxwell, Susskind, and Yang. Of course, the engineering work is important, but it must be followed up by proper testing. Now for some things to consider as we go forward, creating a new kind of building element or building system. Some inspiration. Here's Vienna Gupta's Hexayurt shelters. I just love how this is made just from 4x8 sheets. There's virtually no waste other than what's in the kerf when it's cut, and it's expandable. You can see the variety of structures that can be created just by 4x8 sheets. Nick Sayers did some really interesting things with these domes that he created using rectangular sheets with cuts. They've all hold together themselves with these cuts. It's amazing. From Inhabit.com, we've got the smallest possible geodesic dome that could be used as a house. One of the things I really like here is every element is the same. Every joint is the same. These come from Fuller's 1950s patent on putting sheet goods together to form domes. These shapes and the way they're going together really reminds me that we need to capitalize on things that are out there. Things such as finite element meshing. There could be ways of using the principles of finite element meshing to identify shape structures that could be used to create any building or object or thing of this sort. Also, there's a large amount of work that has been done in terms of geometry and mathematics. We must pay attention to this and not reinvent the wheel. Switching gears a little bit, we need to think about not just how simple pieces can go together, but how more complex pieces could go together. And I'm really inspired by Greg Fleischman's work here. These are emergency shelters, all made by 3/4 inch plywood, and it's beautiful. And again, the concept of expandability or modularity is really a fundamental one here, even in Greg Fleischman's work. Again, switching gears, let us think now about a more complex fundamental building blocks. This is the quad drawer, an amazing new building element developed by Dror Bensitrit. This is called the quad drawer. The quad drawer packs flat and can be opened to create, in essence, a box that can be used then for structures. In essence, it's like a folding brick. One of the things I like about the quad drawer is that it's based solidly in geometry. And what that means then is it can be made from a variety of materials. That kind of flexibility is really, really a valuable thing in my mind. Although this is a rendering, you can see the idea of this being molded out of plastics. You can also start to see that there are some connection pins that exist between the quad drawers so that they can be stacked and held in place. There's a great series of videos and good descriptions of the quad drawer at quaddrawer.com. I really encourage you to look at that and get inspired by some of the things that are discussed there. I got so interested in this quad drawer that I had to make one this weekend. And one of the things I noticed immediately is that there aren't any plans for how to make these things, and it can be a little bit complicated. Most people that I read about on the internet who had made the quad drawer used their table saws. But there's one particular cut that doesn't work very well on the table saw, and it requires some tricky maneuvering. Instead, I made my quad drawer completely using my chop saw. The quad drawer is constructed with 4 identical pieces. In the end, 2 pieces are connected together and 2 other pieces are connected together, and you have 2 moving parts that are interlocked with each other. Once I had them in place, I simply used some nails to hold them together. In the end, this is the quad drawer that I created. One of the things that I like about this is, by the way all the bevel cuts are made, when it's open, everything is either planar or a right angle to itself. So in the end, it's exactly like a box, except it isn't. You can see the hinging movement there, designed to support load on the top, such as this. So in the end, we have an opportunity to put our creativity and engineering skills to work, trying to create a building element that can make a difference in the developing world. A building element that can be used to create furniture, to create housing, to create things of this nature. Whatever we do create has got to be better than the hexayurt. It's got to be better than the quad drawer. And this is going to be difficult because those are amazing innovations in my mind.